Hey everyone, we are going to go ahead and keep moving on in Unit 7. Today we're going to be looking at inverse function values and also I think finding inverses. So we'll see how much we can get through in one video. So our topics are we want to make sure that we understand what an inverse function represents, and if we're given a table of values from a function, if we can find inverse function values or regular function values. And then also being able to verify in an ordered pair sense what inverse functions represent. And then if we're given a function, being able to find the inverse function. So kind of a lot of things, but they're all really closely related. So don't be overwhelmed. All right, so we talk about an inverse function. If we're given any function f of x, we talk about the inverse of x, and we write it like this: f to the -1 power of x. Now this does not mean that we're doing this, 1 over f of x. I know negative inverses, or sorry, negative exponents mean that we flip it, okay? But in this case, this does not represent a negative exponent in that sense, because we're applying it to a function, not to like a number or a variable, okay? This is saying that our f function, we're taking the inverse of it. So when you see this little -1 up here, that just lets you know that this is our inverse function, okay? All right, so what inverse functions do is they basically do the opposite, or they undo what's being done in that given function. So if I look at this one, f of x is the square root of x. This function takes x and it calculates the square root of it, right? It takes the square root of it. So the opposite operation or function, if you will here, of taking the square root is to square it. So for this function, if I wanted to find the inverse function, it would be to take x and square it, because squaring undoes a square root undoes squaring, right? So it's just kind of trying to figure out what is the opposite operation, or the opposite function, or the function that undoes what this function is doing. So same thing with this one. If I have f of x equals x plus 2, well, this is taking my input and adding 2 to it. So if I wanted to find the inverse operation, I would take what I have and subtract 2 from it, okay? And there is an algebraic way to solve for these, which I'll show you later in this section. But I just want you to understand what it is that an inverse does, okay? So notice the original function, what it does is it takes x values and assigns them to y values, right? If I were to plug, say, 4 in here, if I take 4 and take the square root of it, I get 2. That means that we would have the ordered pair 4, 2, right? But if we do the opposite over here and we square it, that means we're going to square 2 to get 4, okay? So it's almost like we're swapping our input and our output in an inverse function, okay? So if the original functions takes x values and assigns them to y values, or f of x values, then the inverse will take y values and assign them to x values, okay? So just as a little short note here, f of x takes x to f of x, right? Or in other words, it takes x to y. So that means that our inverse function takes our f of x back to x, or in other words, our y back to x, okay? So let me just show you what I mean by that using a table. So we have this table that represents the function f of x. So notice here, this is going from x values to f of x values, or in other words, these are our x's and these are our y's, okay? So this function, you plug in an x and you get out a y, right? Now, if we are, or here, let me just write it up here. So if I look at f of x, I'm plugging in an x to get out a y, right? But if I'm doing the inverse, then it's reversed. So if I want to do f inverse of 3, that means whatever's in here, because it takes a y to an x value, my input on an inverse function is actually the y, and we're looking for the x, okay? That's what we're looking for here. So what I'm going to do is, instead of looking for the x to find the y, they're giving me the y, and I have to find the x for that. So if I look at all these all these y values, I can see that 3 is here, right? And 3 as a y value gets sent to or assigned to -5 as an x value. So all this means is that f inverse of 3 is equal to -5. Okay, and it's just as easy as that. So when you have a normal function without the little inverse exponent up there, you're just finding the x and stating the y. If you have the inverse little -1 notation, that means they're giving you the y value and you're having to find the x value, okay? So let's look at a couple more. So I'm just going to use the same table above here to figure out what f inverse of -11 is and also what f inverse of -11 is, okay? So notice we see this little inverse. So when we see this inverse right here, that means that whatever's in here is our y value. So we are looking for x. So I go to where my y value is -11, which is right here, right? And notice the x value that corresponds to that y value is -10. So that means that f inverse of -11 is equal to -10. Okay. Now let's look at the second one. The second one just says f of -11, right? F of -11 is just a regular old f function. Okay, f function without the inverse takes x's and sends them to y's. So that means whatever is inside here is our x value, and just like we are used to doing, we're just looking for our y value. So I go to where x equals -11, which would be right here, right? And x equals -11 sends us to the y value -12. So this means that f of -11 equals -12. Okay, so that inverse notation versus standard notation of a function tells you if you're looking at a y value to find an x, or if you're looking at an x value to find a y. Okay, does that kind of make sense? Maybe a little bit. All right, so on the next page, there is one for y'all to try using the same idea. Okay, go ahead and take just a couple of minutes and identify what f inverse of -3, f inverse of 5, and f of 6 equal. Go ahead and pause the video and then play it when you're ready to see the answers. All right, so let's go ahead and go over the practice. When I look at this first one, it's an inverse function, right? Inverse. So inverses take a y value and assign them to an x. So I need to go to where my y value is -3, which would be here, right? Because this is my x, this is my y. And my y value of -3 is tied to the x value of -5. So this just equals -5. Okay. We look at our second one, it also is an inverse function, right? It's an inverse function, which means that takes a y and sends it to an x. So my y value here is 5. So I go to where my y is 5, which would be right here. And I look at the corresponding x value, which would be -3. Okay. And then our last function, notice here, is just a regular f function. Okay, it's not an inverse. So regular functions take x's and send them to y's. So that means that x is 6. So I go up here and look for where x is 6, and it's this last value here. Okay, and when x is 6, notice y is +7. Right? Are we kind of okay with seeing which way we're going, depending? All right, so we should be able to do the same thing with ordered pairs. We should be able to take this written as an ordered pair in our inverse function would be -3, -5. Well, this same ordered pair would be in our original function, except they would be swapped, right? So that's what these next examples are going to show us. So this one says, you are told that h is one-to-one function. Okay, when you see that it's a one-to-one function, that means that it has an inverse. Okay, so anytime you see that it is a one-to-one function, or we've made a one-to-one function, or we've created a domain that allows a one-to-one function, all that means is that it passes the horizontal line test and we have an inverse. Okay, so it tells us that it has values of h of -6 equals -12, and h of 8 equals -2. Okay, so that means in our h of x function, if we were to write these ordered pairs, okay, -6 is our x negative 12 is our y, right? So it takes negative 6 and sends it to negative 12. We also know that h of 8 equals negative 2. So this is our x and this is our y. So we have the ordered pair 8, negative 2. Okay, so that's what we know about our original function. Now, our inverse function, remember, goes the opposite direction. It sends y's to x's, which means that if I wanted to talk about h inverse, the information that was given to me about the original means that all I would do is swap these. Swap. So I would end up with the point negative 12, negative 6, negative 2, 8. Okay? So this is what I know to be true about my inverse function. So I just want to write these ordered pairs as mathematical statements like we were given. Okay? So if my input is negative 12, that means that h inverse of negative 12 equals negative 6. It also means that h inverse of negative 2 equals 8. So this is the one thing that we can deduce here, right, from the information given, is basically we can swap those values and create new mathematical sentences. So in your Knewton assignment, it's going to give you multiple choice to see if you really understand that connection between a function and its inverse. So it says select all the correct answers. Okay, which of these must be true? So I look, does h of negative 6 equal 12? Well, I'm just going to compare it with the two things I know to be true, and that is not true, right? No. Does h inverse of 8 equal 2? Do I look and see if that's one of my true statements? It's not. So that's not true. Does h inverse of negative 2 equal 8? Well, yes, that's one of the true statements that I got. So that one is going to be an answer. Okay. Does h inverse of negative 12 equal 2? Well, I do have h inverse of negative 12, but it equals negative 6, not 2. So that one is not one. Then we have h inverse of negative 12 equals negative 6. That is the first true statement that I came up with. Okay. And then notice I only had 2 true statements here. So now that I have 2 answers, I can pretty much assume the last one is incorrect. But if you want to double check it against your true statements, you can see that it is in fact not true. Okay. So we only have 2 answers to that one. Okay. All right. So let's look at another one. Another way that we can identify inverse function values is from a graph. So just like we used with the table, we have to identify, are we given a y and we're looking for an x, or are we given an x and we're looking for a y, okay? And that's based on whether we have a regular f function or if we're looking at the inverse, f inverse, okay? So it says here, we're given this function f of x and the graph is shown here. So remember, these are our x's, these are our y's. Okay, or f of x's. So if I look at this first one is an inverse function, right? Inverse function means that the number inside here is a y. So if we are given a y, that means we're trying to find the corresponding x value, okay? So what I want to do is I want to go to where y equals 3. So on my y-axis, I go to where y equals 3, which is right here, and I'm just going to trace it over until I hit my graph. So it hits my graph at this point, and you can see at that point that my x value is 1. So that means that f inverse of 3 equals 1, because this is the x value that corresponds to the y value that was given. Does that kind of make sense? Let's look at a couple more. The second one is also an f inverse. Okay, when we're looking at inverse, that means that the number in here is a y. Okay. And if it's a y, that means we're looking for an x. So I'm going to go to where y equals 5. So I go up on my y-axis until I get to 5. And I'm going to trace it over until I hit my function. I hit my function at this point, and then I just drop it down to see what is the x value of that point. And the x value of that point is at positive 4. So this just equals 4. Okay. And then our last one, notice it looks a little bit different, right? This is just a regular old f of something. So if it's a regular function, that means we're taking our x value and tying it to a y value. So this time, instead of looking at the y-axis, I'm just going to go over to where x equals 3. So I'm going to go on the x-axis over to 3, which is right here. I'm going to trace it up until I hit my function, which is at this point, right? And then I'm going to look over to see what y value I get at that point, which in this case is a positive 4. Okay, so it's the same thing we were doing with the table on the last page, but we're just using a graph instead. Okay, all right, so on the next page, there are 2 practice problems for you to try. So go ahead and take a moment to pause the video and work those out. And then when you're ready to check yourself, play it and we'll see how you did. All right, so let's go ahead and look at the practice problems that you just did. Number 1, we're given that g sends -7 to 8. That means in the inverse function of g, 8 will be sent to -7. Okay. We also are given that g is sending -2 to 6. So in our inverse function of g, 6 would be sent to -2. So go ahead and write out your true statements first and then use those to determine which of the following are true. So all I have to look for is the 2 that I found to be true, which is that g inverse of 8 equals -7 and that g inverse of 6 equals -2. So only the third and fifth options are solutions to this problem. Okay. All right, and then we look at one where we are given a graph. When we're given a graph, anytime we see the inverse, that means that we are looking for the x value because the y value is given. So you can see here that when we go to where y equals 4 and we trace it over, the corresponding x value is 6. Okay. On the next one, we're given a regular function, so that means the number inside the parentheses is an x. So when x is 4, if I trace that down to my graph, it's going to hit and give me a y value of -1. Okay. Our third one is an inverse function. So if it's an inverse function, that means that we're given a y value, and here the y value is -3. So I'm going to go down the y-axis until I get to -3, trace it across till I hit my graph, and notice the corresponding y value here is 2. Okay. And then our last one is f of 6. So if I go to where x is 6, that's on my x-axis, I trace it up till I hit my function value, and then I look for the y value at that point, which is +4. Okay, so hopefully we're kind of okay with going back and forth between f of x and f inverse of x. So that is all of this section. So you should now be able to complete your inverse function values assignment on Knewton. If you have any questions, please let me know.